In 1980, a digger was a strong, dumb animal. Pull a lever, oil moved, dirt flew. 10 years later, machines were thinking, reading pressure, choosing power modes, saving fuel while you dug. And in a Chilean copper mine, one German monster weighing 475 tons proved a hydraulic shovel could do what only rope shovels had done. These 10 machines rewrote the rules. Number 1 is still on job sites today. Number 10, the Bobcat compact excavator. Let's start small. Very small. Through the 1970s and early 80s, the American construction site had a rhythm to it. If the job was big, you brought a full-size crawler excavator. If the job was small, a trench beside a house, a drainage line in a backyard, a footing between two existing buildings, you brought men with shovels, or you brought a backhoe loader and hoped the property owner didn't watch too closely as you crushed their lawn. Japan had already solved this problem. Takuchi built what is widely recognized as the world's first compact excavator, the TB1000. All the way back in 1971, a machine with a full 360-degree slew in a body small enough to work where a full-size digger simply couldn't fit. Kubota and Yanmar pushed the idea further. In dense Japanese cities, where lots are narrow and buildings sit shoulder to shoulder, that made obvious sense. North America was slower to believe. Then, in 1986, Melrose, the North Dakota company behind the Bobcat skid steer loader, added compact excavators to its product line. And that single decision mattered enormously. Not because Bobcat invented the mini excavator, but because Bobcat had something nobody else had. A dealer network that reached deep into small-town America and a brand that ordinary contractors already trusted. Suddenly, the one-man landscaping outfit, the small plumbing contractor, the rural utility crew, people who would never in their lives buy a 20-ton crawler, could rent or finance a machine that did real excavation work. That is the quiet revolution of the 80s. Not bigger, smaller. The compact excavator turned excavation from something a company does into something a person does. It put hydraulic digging power in the hands of two-man crews, and it created an entire equipment category that today is one of the biggest selling segments in the whole industry. You can barely drive past a residential job site without seeing one. Every mini excavator digging in a backyard right now traces its commercial breakthrough to this moment in the mid-1980s. Small machine. Enormous consequences. Number 9. Hyundai's Robex series. In 1980, if you were buying an excavator, you were buying American, European, or Japanese. Full stop. There was no fourth option. By the end of the decade, there was, in February 1985, Hyundai Heavy Industries, a company the world knew for building enormous ships in Ulsan, South Korea, set up a construction equipment research and development operation. That's it. That's how it started. Not with a machine, but with an R&D department inside a shipyard company. In 1987, that operation was spun out as a proper construction equipment division, and the first phase of a dedicated factory was completed. In August 1988, Hyundai developed its own excavator models, a 21-ton machine and a 29-ton machine designed in-house rather than licensed from someone else. And in 1989, the company launched the Robex series of medium-sized excavators, expanded the factory, and became an independent heavy equipment business. Now, why does this belong on a list of machines that changed construction forever? Because of what happened next. The Robex line was the beachhead. Within a decade, Korean manufacturers were shipping excavators worldwide. Within 2 decades, Hyundai and its Korean rival Daewoo, later Doosan, were serious global competitors, and Doosan would go on to own Bobcat itself. The center of gravity in the excavator world shifted, and the price of a capable machine came down for everybody, everywhere. If you are a contractor in India, Africa, South America, or Eastern Europe today, and you are looking at an excavator that costs meaningfully less than the premium brands but still digs all day, you are living in the world the Robex series opened up. The 80s were the decade the excavator business stopped being a closed club. Number 8. The Caterpillar 245B. Caterpillar came late to hydraulic excavators. Deliberately, While European and Japanese makers were experimenting through the 1960s, Caterpillar sat back and watched other companies struggle with leaking hydraulics and unreliable pumps. CAT's engineers ran feasibility studies for years, built a prototype known as the X1 in 1968, and only launched their first customer-ready hydraulic excavator, the 225, in 1972. Then the 235 arrived. Then, in 1974, the big one, the 245, weighing around 72 tons. It became the machine of choice for quarries and mines that wanted hydraulic flexibility with serious mass behind the bucket. And here's where the 80s come in. In 1988, Caterpillar introduced the 245B, and the changes tell you exactly what the decade was about. The CAT 3406T engine was uprated to around 360 flywheel horsepower. A new hydraulic pump went in. And critically, the operating weight came down to roughly 65 tons. Think about that. More power, less weight. That is the entire engineering philosophy of the late 1980s compressed into one machine. Manufacturers had stopped trying to win purely by making things heavier and started winning by making things smarter, better hydraulic circuits, better pumps, better power to weight. The 245B stayed in production until 1992, when the 245D took over with an even more powerful engine and upgraded electrical and hydraulic systems before Caterpillar's newer 300 series machines eventually replaced the whole family. The other thing Caterpillar did in the 1980s deserves a mention here too. In 1984, CAT began marketing German-built ER excavators, which filled out the small end of its range and brought the first rubber-tired wheeled excavators onto CAT's books. So the 245B represents the decade. Caterpillar stopped being a newcomer in excavators and became a heavyweight. And the moment the industry accepted that a hydraulic machine could hold the quarry face all day long. Number 7. The Liebherr A912 Litronic. This one is the sleeper pick on the list. It doesn't look like a revolution. It looks like a fairly ordinary wheeled excavator. But it's the machine that made excavators think. Some background. Liebherr was founded in 1949 by Hans Liebherr in Kirchdorf an der Iller in southern Germany, and by 1954 he had built the L300, a wheeled excavator that Liebherr describes as the first hydraulic excavator in Europe. The company had a philosophy from the start: build the key technology yourself, don't buy it in. You can see that philosophy fully realized in 1983 with the A912 wheeled excavator. On that machine, Liebherr made the diesel engine, the hydraulic pump, the slewing drive with its planetary gearbox, the excavator axles, and the gearbox and transfer box in the undercarriage, all in-house. Then, in 1989, Liebherr introduced Litronic, and it went into the A912 Litronic first. Litronic is not a gimmick name. It's a complete system of electronics and hydraulics working together to monitor, control, and coordinate all the key systems of the excavator. The engine and the pumps stop being two separate things that happen to be bolted together. They become one managed system, constantly adjusted, constantly matched to what the operator is actually asking for. This is a genuine turning point. Before, an excavator was a hydraulic machine with some wiring. After, an excavator was an electro-hydraulic machine, a computer that happens to move earth. Every intelligent feature you enjoy on a modern excavator descends from this idea. Automatic power matching, fuel-saving modes, on-screen diagnostics telling you what's wrong before you've even opened the engine door, grade control, machine guidance, and Litronic didn't disappear. It's still the name on Liebherr machines today, decades later, in evolved form. The A912 Litronic isn't famous, it should be. Number 6. The Komatsu PC50UU-1. Here is a problem that killed jobs, damaged property, and injured people for decades. The counterweight. On a conventional excavator, when you swing the upper structure, the back end swings out well beyond the tracks. On an open site, that's fine. On a city street, next to a wall, next to a parked car, next to a live traffic lane, it's a menace. So through the early 1980s, several Japanese manufacturers began chasing the same solution: build an excavator whose body can rotate within the width of its own crawler tracks. Komatsu's own account is refreshingly honest. This development race was underway by 1982, and Komatsu was one of the later companies to join it. But when Komatsu did commit, it committed hard. The PC50UU-1 arrived in 1987. It was based on the existing PC40 with a turning radius of 1 meter, an operating weight of around 5,100 kilograms, and a bucket of roughly 0.2 cubic meters. And the engineering challenge was brutal. Everything had to shrink: the plumbing, the control devices, the bodywork, all of it repackaged into a tighter envelope without wrecking the machine's balance or its dig performance. It worked. The machine was well received in the market, and in 1987 it received the G-Mark Good Design Award from Japan's Minister of International Trade and Industry. Now, think about what that unlocks. Urban construction, road repairs with a live lane of traffic beside you, demolition inside an existing structure, utility work in an alley. Any job where the constraint isn't how hard you can dig, but how little space you can dig in. Today, zero tail swing and short tail swing are standard categories in every manufacturer's catalog, and in dense cities, they're often the only machines allowed on the job at all. The PC50UU-1 sits right at the beginning of that lineage. The 1980s taught excavators to be polite. Number 5. The Liebherr R994. Some machines change construction by being clever. This one changed it by simply refusing to stop. The Liebherr 994 was a 250-ton class mining excavator, and it entered production in 1986. That is a mining machine designed in the mid-1980s. Here is the astonishing part. It stayed in production and stayed relevant for over a quarter of a century. It wasn't replaced until Liebherr introduced the R9250 as its successor, a machine powered by a 12-cylinder Cummins diesel rated at around 960 kilowatts, offering roughly 15% more bucket capacity and 42% more swing torque than the R994 it replaced. Read that again. To beat the R994, Liebherr needed decades of engine, hydraulic and electronic development, and even then the gains were measured in percentages, not multiples. That's not a criticism of the R9250. That is a monument to how right the R994 got it the first time. What did it change? It hardened the 1980s consensus that the biggest earth-moving jobs on the planet, overburden stripping, ore loading, mega infrastructure cuts, belong to hydraulic excavators, not rope shovels, not drag lines. Hydraulic machines which could be moved, reconfigured, fitted with a backhoe or a face shovel, and matched to a truck fleet. Every mine planner who now specifies a big hydraulic excavator instead of an electric rope shovel is standing on a decision the 1980s made for them. And there's a bigger lesson buried here for anybody who buys equipment. The best machines aren't the ones that are exciting in year 1. They're the ones that are still earning money in year 25. Number 4. The Hitachi EX200. Hitachi spent the 1970s proving it could build very large hydraulic excavators. In 1979, the company delivered the UH800-1, an ultra-large machine that Hitachi's own records describe as the largest in the world at the time, and it went to a mining customer in North America. Then, in 1987, Hitachi went further and launched the EX3500. An ultra-large hydraulic excavator that Hitachi's corporate history lists as the largest in the world at the time of its launch. In the same year, the company also launched the EX1800 as the direct successor to the UH800-1. On-screen text. Claims of world's largest depend on how you measure. Now, honesty matters here, so let's be precise. Largest in the world is a claim manufacturers make in different ways, by weight, by bucket capacity, by engine output. And as you'll see in a moment, there was already a German machine on this planet that weighed considerably more. So take the superlative with the caution it deserves. But what nobody disputes is the significance. The EX3500 confirmed that Japan could compete at the absolute top end of mining equipment, not just in the 20-ton class where Japanese machines were already dominant, but in the heavyweight, hundreds of tons, mine-scale category that had been the preserve of German and American engineering, and it slotted into a strategy. Look at what Hitachi did in this single decade. A technical tie-up with Deere & Company in 1983, a joint venture with Fiat in Italy in 1986, ultra-large mining machines in 1987, and then in 1988 the establishment of Deere Hitachi Construction Machinery, which began building hydraulic excavators inside the United States in 1989. That's not a product line, that's an invasion, planned, funded, and executed inside 10 years. The EX3500 was the machine that said, "Whatever size you need, we can build it." Number 3. The O&K RH300. Now we get to the monster. Orenstein and Koppel, usually just called O&K, was a German engineering firm founded in Berlin in 1876 by Benno Orenstein and Arthur Koppel. It built railway vehicles, then heavy equipment, and in 1961 it produced Europe's first series-built fully hydraulic excavators. And then, at the turn of the 1980s, O&K built something that made the entire industry recalibrate. The RH300 was documented in a technical paper published by SAE in 1981, and the numbers in it are still staggering. A service weight of 475 metric tons, engine output of 1,730 kilowatts, about 2,350 horsepower, a shovel capacity of up to roughly 40 cubic yards. At the time, it was described as the biggest and most powerful hydraulic shovel in the world. It was purpose-built for a specific mission: open-pit mining. Strip the overburden, load the ore, at a scale nobody had achieved hydraulically before, and it went to work in the most demanding place imaginable. By the late 1980s, a paper presented on the RH300 described it operating at Chuquicamata in Chile, the world's largest copper mine, a pit that has been producing since 1915 and has had billions of tons of material dug out of it. Here's why this matters far beyond mining. Before the RH300, there was a widely held belief that hydraulics had a ceiling. That past a certain size, the pressures, the flows, the heat, the sheer engineering of it would defeat you. And beyond that ceiling, you had to use rope and electricity, like the great cable shovels always had. The RH300 broke that ceiling in public. Everything huge and hydraulic that followed. O&K's own RH120 and RH200 stripping overburden at British open-cast coal sites through the 1980s. The giant machines from Liebherr, Komatsu, Hitachi, and Caterpillar that dominate mining today exists in a world where that question had already been settled. One German machine, one enormous statement. Number 2. The Hitachi Landy X Series EX200. In 1986, Hitachi launched the Landy EX series of hydraulic excavators, and the headline feature was electronic control. That phrase sounds unremarkable in 2026. In 1986, it was a philosophical shift. Up to that point, an excavator's performance was determined by its hardware and by the man on the levers. If the machine wasted energy, and they wasted a lot of it, that was simply the cost of doing business. Oil got pushed around. Pressure got dumped across relief valves. The engine roared at full revs whether you were ripping rock or trimming a slope. The Landy EX series introduced electronics that managed how the engine and the hydraulic system worked together. And the industry noticed. The series received an Energy Efficient Machinery Award and a Machinery Industrial Design Award. Energy efficiency in an excavator. In 1986. That is the whole story of the 1980s in one product. And the EX200 in particular, a machine of roughly 18.5 tons with about a 1 cubic meter bucket in its late 80s form, became one of the most recognizable excavators on Earth. Hitachi's Super EX200 was built around a turbocharged, direct-injection Isuzu diesel with a high-power mode the operator could call up on demand and a cab that was, for its time, unusually spacious and comfortable. Comfort mattered more than anyone admitted. A tired operator digs slowly and makes mistakes. A wide cab with real legroom and a proper door is not a luxury. It's a productivity feature and a safety feature. Then Hitachi did the thing that turned a good machine into a global one. In 1988, it established Deere Hitachi Construction Machinery with Deere & Company, and from 1989 hydraulic excavators were being manufactured locally in the United States. The EX bloodline flowed into John Deere's excavator line, and the Deere-Hitachi partnership ran for decades. An electronically controlled, fuel-efficient, operator-friendly 20-ton excavator built in America under a legendary American brand. The 1980s didn't just change machines, it changed who built them and where. Number 1. The Komatsu PC200 and the OLSS revolution. And here it is, the most consequential excavator story of the entire decade. And it starts with a divorce. For years, Komatsu had built excavators under a technical partnership with the American manufacturer Bucyrus Erie. In 1980, Komatsu ended that arrangement and launched the PC series as its own independent brand. That is a company betting its future on itself. The first-generation machines, the PC1 series, launched in 1980, already carried a serious idea. They used a pump-neutral system, which cut the discharge from the main pump when it wasn't needed, reducing wasted power. The PC201 weighed about 18,500 kilograms, with a bucket of around 0.7 cubic meters. That is, near enough the exact size class that still dominates construction sites worldwide. But it's what happened in 1982 that changed everything. 2 years after the PC1, Komatsu launched the PC200 with OLSS, the Open Center Load Sensing System. It was the first function of Komatsu's energy-saving hydraulic system, and the concept is beautifully simple to explain and fiendishly difficult to engineer. An excavator's pump is dumb. It pushes oil whether or not the oil is needed. When the levers sit in neutral, or when the operator is doing fine, delicate work, huge amounts of energy get thrown away as heat and noise. Oh, SS listened. It sensed what the machine was actually being asked to do, and it cut the losses, the neutral loss, the fine control loss. The result was a large reduction in wasted energy, plus better starting and less noise. Fuel is the single biggest running cost a contractor faces after labor. A machine that does identical work while burning meaningfully less diesel is not a nice-to-have. It is a business advantage, every hour, every day, for the entire life of the machine. And Komatsu didn't stop. The PC3 series arrived in 1984 with electric OLS engine controlled by electronics, and it was well received. Then, 3 years later, with competition heating up, Komatsu redesigned the whole thing and launched the Avance series in 1988. On the Avance, the operator selected from 4 working modes: heavy excavation, correction, and fine operation, and the machine automatically set the appropriate power mode for the task. The PC205 in that series weighed around 18,900 kilograms with a 0.7 cubic meter bucket. The Avance sold so well that Komatsu released a special Avance limited edition to mark 10,000 units, and the range around it exploded through the decade. The PC1500 and PC400 in 1981, the PC650 in 1983, the PC1600 in 1987. But it's the 20-ton PC200 that changed construction forever, because the PC200 became the default, the benchmark, the machine that competitors were designed against. Go to a construction site in India, in Indonesia, in Brazil, in Europe, in Africa, today, and you will find a 20-ton excavator with a roughly 1 cubic meter bucket doing the bulk of the world's earth moving. That size class is the workhorse of the planet, and the modern version of that machine, sensing load, managing pump output, selecting power modes, saving fuel, is doing exactly what Komatsu's engineers set out to do in the early 1980s. If you enjoyed this, subscribe, because next time we're going into the machines that came after the 1990s, when the computer truly took over the cab. Thanks for watching.